Let's graph exponential functions. So here's some reminders about transformations, stuff that we learned way at the beginning of this year. All right, so first thing we talked about was what the h did. The h shifted our function left and right. And the h was always the opposite of what our brain wanted us to do. So if the graph was going to the right, then the h would say minus h. And if the graph was going to the left, then it would say plus h. All right, h is always the very first movement. Next, if your x is negative, then the graph is going to reflect over the y-axis. Hopefully you guys remember this stuff. If not, make sure you take a picture of it while we're going through it. All right, next, if there's a negative on the outside, then it's going to reflect over the x-axis. And this order is very important, so pay attention to the numbering. And then last, the k shifts the function up and down. Once again, if you don't remember this stuff, please take a picture of it right now. Pause the video. And now we're going to talk about the exponential functions. Transformations for exponential functions look pretty similar to transformations for all the other functions we did this year. The only new thing now is everything looks a little different. Everything that was in parentheses is now up in the exponents place. Also, we have a base now, and that base can be any number, but it's only going to affect the direction of the graph, but we'll talk about that in a little bit. The h is going to still shift our function left and right. If our x is negative, our function will still reflect over the y-axis just like in the previous slide. If there's a negative on the outside, it's going to reflect our function over the x-axis, and the k will still shift our function up and down. Now remember here, the order matters, okay? So make sure you go in the correct order when you're performing these transformations.
All right, guys, before we start graphing exponentials, I need to show you what their parent functions look like. No matter what the base of an exponential function is, that parent function will always have a point at 0, 1. The reason for that is because anything raised to the 0th power is equal to 1, right? Like if I were to raise 5 to the 0th power, that'd be equal to 1. If I were to raise 25 to the 0th power, that's equal to 1. So yeah, each of these parent functions will always have a point at 0, 1. Now, the base affects whether the function increases or decreases overall. If the base is bigger than 1, so I've got some examples here. If the base is bigger than 1, then your graph is going to generally increase. If the base is between 0 and 1, see the examples here, then your graph is going to generally decrease.
Go ahead and take a picture of this image. It'll be pretty important for today's lesson.
All right, guys, so before we start graphing exponential and functions, it's important for you to know that exponential functions have horizontal asymptotes, and their horizontal asymptotes happen at y equals k. A horizontal asymptote is just a restriction, and it's a restriction that's a horizontal line. All right, we'll get to that in the last step of graphing these. But first we're going to list out the transformations according to our equation. There's a negative x in there, so this guy is going to reflect over the y-axis. That number 2 is letting us know that this graph is going to increase overall, starting off anyway. Anytime the base is bigger than 1, it starts off increasing. And then the plus 1 is letting us know that this graph is going to go up 1 at the end. All right, so now I'm going to plot a point at 0, 1, and I'm going to start shifting this bad boy. So I'm going to reflect it over the y-axis, which leaves this point here, but changes the shape. Reflecting over the y-axis means now the shape will look like this. All right, and then from that green point, we're going to go up 1 now, and that'll be our final movement. So going up 1 right here. Going to draw in my new shape, put my flat looking end over there. And then now that we've gotten through steps 1 through 3, now we'll just sketch in the horizontal asymptote, and then we'll be done. So the horizontal asymptote happens at y equals k. So that means this horizontal asymptote happens at y equals 1. So it'll be right here. Now, once again, a horizontal asymptote is a restriction, right? So it's not going to pass it, touch it, or cross it. It's just going to get really, really close to it, and that's all. All right, so when you are graphing these bad boys, here's what I'll be looking for. I want to make sure you're shifting around the correct point and it's in the right place. I'm looking at the shape to see if your final shape looks exactly the way it should. And I'm also looking for you to draw in the horizontal asymptote. All right, let's do another one. So on this next one, I'm going to start it off the same way. Let's follow these steps here. Let's list the transformations. So it says plus 2, so this guy's going to go to the left 2. And then it says minus 1 at the end, so after that he'll go down 1. The base is 3, so this guy will generally increase starting off. And yeah, that's it so far. All right, let's start. Gonna put in my point at 0, 1. We're going to shift this around. We're going to go to the left 2 first, and then we'll go down 1. Left 2, 1, 2. Down 1. All right, going to draw in my new shape. Now, no reflections happened here, so the shape just is the way it originally started. We've got the flat end, or the flat looking end over here, and then it goes out. And let's put in our asymptote, and then we're done. The asymptote happens at k, and so the asymptote is at y equals -1. And that's it. All right, let's do the next one. Okay, we're going to follow these steps here. So we're going to list the transformations first. It says -1, so it's going to go to the right one first. And then there's a negative on the outside, so reflect the x-axis. And let's look at what the shape will look like. Our base is between 0 and 1, so this guy's actually going to start off decreasing. And here we go. Point at 0, 1, and we start with the shifting. We're going to shift it to the right one first. And then we will reflect him over the x-axis. Now the reflection is going to change the original shape, so pay attention to this. Originally, he looked like this up here, right? Well, when he reflects, now he's going to be like this. All right? So let's put that shape in there correctly. And let's put in the asymptote. Now for this guy, we don't have a k there, but technically the k is 0 because this guy didn't go up or down. So just 1 unit away from that point is where my asymptote will go, right here at y equals 0. All right, let's do another one. All right, we're going to follow these steps once again. We're going to list out the transformations. This guy goes to the left 2 because it says +2. And then x is negative, so reflect the y-axis. Put my point in there at 0, 1, and here we go. Now, think about what the shape is. The base is 1/3. That's between 0 and 1, so it's going to start off decreasing. Now, the reflection might change the shape, or it will change the shape. All right, so here we go. I'm going to go to the left 2. And then I'm going to reflect that point over the y-axis. And I'm just counting when I'm reflecting. I'm like, okay, y-axis is here. This point's 2 units away. When he reflects, he should be 2 units away. Okay, let's think about what the shape will look like when it reflects. Originally, originally it looked like this, but when it reflects, it's gonna look like this, right? So I'm gonna draw that shape in there. And then put my asymptote in there. Once again, we didn't have a K explicitly written there, but since this graph isn't going up or down at all, K is just 0. So the horizontal asymptote is at y equals 0. Let's try one more. All right, so going to follow these steps once again.
The equation says +2, so it's going to go to the left 2. The negative on the outside will make it reflect over the x-axis, which will change the shape of the graph. And then the -3 will make it go down 3. Now, I'm going to write here down 1, but I just made a mistake when I was recording myself writing, so my bad. It should say down 3. Okay, so now we're going to think about what the shape of this graph looks like. The base is 12. That's greater than 1. So overall, this graph will increase. All right, so now we're going to plot that point at 0, 1 and start shifting that bad boy. Let's take that point to the left 2 first. So 1, 2 should be right here. Now we're going to reflect it over the x-axis, and I'm just counting away from the x-axis to see how many units away it should be on the other side. Now remember, reflections change the shape. So originally this guy looked like that purple graph I drew up there, but now when he reflects, he's going to flip over the x-axis, so now he'll look like that. And then last, we're going to shift this 3 units down. Now, once again, I made a mistake when I was recording this, so just give me a chance to fix my mistake right now. It's about to do the wrong thing. There we go. Now we're down 3, and there's our new shape, and we're going to put in the horizontal asymptote at y equals -3. Guys, remember at any point in this video, you can pause it or rewind it if you need to.
All right, guys, well, congratulations, you made it to the end of this lesson. Reach out to me with any questions you have. You can text me or email me or message me on Canvas. Have a great weekend, and I'm excited to see you guys again on Monday. Bye.